This is Jeff Wise, and I want to welcome you today to our maths lesson. And I always keep on telling you that mathematics is fun and maths is life. Now today I'll be taking you through volume, and we'll be looking at volume of cubes, volume of cuboid, and maybe volume of cylinder. And above that, we'll also try and see how do you convert volume from one unit to another. Therefore, very quickly, we can begin by looking at volume of a cube. Volume of a cube. Now, I believe most of you've come across shapes that resembles a cube, and a cube you'll find that is almost the same as a cuboid, but what makes a cube different is because the length, the width, the height is the same. That's why we say that a cube has side, and side, because all the sides are the same. Therefore, considering an example here, if we have a cube of this kind, let me try to draw one here. Now, if that is our cube, we are saying that a cube, all the sides are the same. And that's why we say it has side by side by side. Therefore, the length, the width, and the height is the same. Therefore, when you want to find the volume of a cube, we use a common formula, and this formula we will use it in all the other shape. That is the base area times height. The base area times height. Therefore, assuming that our cube is of side, let's say side 7 centimeter by 7 centimeters and by 7 centimeters, then the volume of this cube will be given by the base area. The base area is a rectangle. If you can look at this is the base, that is the base. Therefore, the base area will be 7 times 7, and of course now the height is 7. Therefore, this will give us, that is 7 times 7, which is 49, then times 7. And therefore, the volume of such a cube will be given by 7 times 7 times 7, or just 49 times 7, and that will give us 343 centimeters cubic. You get? Therefore, anytime you come across a shape, or it can be a tank, or that resembles, that is a cube, you just use the formula base area times height. The base is a square, therefore it is side times side, which is 7 times 7, then later times 7, which is the height, and that gives us the volume as 343 centimeters cubic. Now we can move on to another thing, and let us now look at volume of a cube. Volume of a cuboid. Volume of a cuboid. Now, we can look at an example here. Let me try to draw for you a cuboid here. There we go. Now, a cuboid is just, it can resemble, a carton, anything, yeah? There are so many shapes that resembles a cuboid, and I believe even at home, Even at school, you can be able to identify some of the shapes that are in cuboid. Now, even looking at the textbook that I'm using here, you can see that this textbook resembles a cuboid because it has the length, it has the width, and definitely it has the height. Therefore, this is also an example of a cuboid. Therefore, a cuboid should have, that is, the length, should have the width, and should have the height. You get? Therefore, using the same formula, and that's what I'm saying, when you're finding volume over cylinder, volume over cube, volume over cuboid, let us master this formula. It's very simple, and you can use it when you're working out the volume of these three shapes. That is base area times height. Therefore, we'll still apply the same formula here, and we are saying that volume is given by base area times height. Therefore, if we can give our cuboid measurement so that we can have the width as 30 centimeters, then the length we can have it as 50 centimeters, then the height we can have it as 42 centimeters. Therefore, when it comes to volume, volume will be given by the base area, and of course the base area here resembles a rectangle. You can see the base there, that is the base, and the base resembles a rectangle, and area of a rectangle is given by length times width. And because our length is 50 and the width is 30, therefore it is 30 times 50. I hope we are together up to that point. Then later we will multiply by height, which is 42. Now 30 times 50, that is 1,500. Of course, it will be in centimeters squared. Then after that, we will multiply by the height, which is 42. And of course, 1,500 multiplied by 42, that gives you 63,000. It gives you 63,000 centimeters cubic. You get? 63,000 centimeters cubic. Therefore, that is the volume of our cuboid, and that is now the base area, which is 30 times 50. Then later you can multiply by 42, which is the height, now to get the volume of the cuboid, which is 63,000. I want to believe up to that point we are together. Now, as we come to the last shape, I want us now to look at volume of a cylinder. Volume of a cylinder. Volume of a cylinder. Now, as we look at the volume of a cylinder, I believe at home you can identify so many objects that are at home that resembles a cylinder. Volume of cylinders. Now, just to represent, this is how a cylinder looks like. Let me try to draw one here for you, so that as we find the volume of a cylinder, at least we can have something that resembles a cylinder. Now, looking at our cylinder here, of course, we are saying volume of a cylinder, we still use the same formula, that is the base area times height. The base area times height. That is, of course, a cylinder has a height, and of course now this is the base area. That is the base area. Now, because the base resembles a circle, either you will be given the diameter, of the circle, or you'll be given the radius. And it is very easy. If you're given the diameter, maybe let's assume our diameter is 28 centimeters. If the diameter is 28 centimeters, therefore the radius is a half of the diameter. Therefore, I expect the radius of this circle, if the diameter is 28, to be 14 centimeters. That is what resembles what? That is what we resemble the radius. Are we together? That is what we resemble the radius of our circle there. Now, we can use this as an example where we can use the height of these cylinder. Let's assume it's 40 centimeters. 40 centimeters. Therefore, when you come to work out the volume of a cylinder, this is what you do. You find the area of the base, then later you multiply by the height. Now, this formula is important. You need to be keen with the shape of the base. Now, the base here resembles what? It resembles a circle. And how do you find the area of a circle? I know, sometimes students, you make mistakes and you confuse between perimeter of a circle, area of a circle, and sometimes, I know, the challenge is how to master all this formula. But you just need to keep on practicing until you get it right. Therefore, area of a circle is given by pi r squared. Pi r squared. Therefore, the base here will be given by 2 pi r squared. That is what resembles the base, because the base is a circle. Then later we multiply by height, and that's why we say that volume of a cylinder is given by pi r squared h. Good. Now, let's work together. We can use pi as 22/7, it's a constant, or in decimal you can use it as 3.142. Therefore, the volume of a cylinder will be given by the base area. The base area will be given by pi r squared, where pi is 22/7 times the radius. What is the radius of our circle here? It's 14. 28 we said it is the diameter. Therefore it will be times 14 because it is r squared. Then after that we multiply by height, which is 40. You get this? Therefore, we can try to simplify this by 7(1) by 7(2). Therefore, we are left with 22 times 2, and that is 44. And 44 times 14 is 616. Then you later multiply by 40 so that you get the volume. Therefore, 616 times 40, you get 24,640 centimeters cubic, and that is the volume of a cylinder. As simple as that. Sometimes the examiner will give you a half a cylinder. Therefore, what do? You use the same formula, then at the end, if a cylinder is a half, you just divide your answer by 2. Because sometimes you may come across a half a cylinder. Let me try to illustrate it here. Yeah, something of this sort. You may come across this. This is a half a cylinder. Therefore, in case you come across such a shape, the formula is the same. But what you do, as you work with pi r squared times h, then later you times by a half, because it's half a cylinder. Therefore, the same formula we are using for volume, that is pi r squared times h, later you just multiply your answer by a half, because this is a half a cylinder. Therefore, you don't need to get confused as you work out the volume of a cylinder. Now, to summarize all this together, to sum up this together, and probably leave few questions for you to find, that is the volume of different shapes. After finding the volume, you'll find that this topic on volume is combined with capacity. It's combined with capacity. And capacity, this is where we calculate volume in terms of liters, in terms of milliliter, because those are the basic or the major ones that we use. The only thing you need to understand under capacity, you need to understand the relationship, some mathematical relationship between centimeters cubic and liters, liters and milliliter, and maybe liters and meters cubic. Therefore, there's some relationship that you need to remind yourself that 1 liter is equivalent to 1,000 centimeters cubic. And again, 1,000 liters is equivalent to 1 meter cubic. And again, you need to understand that 1,000 milliliter is equivalent to 1 liter. Therefore, these are some of the things that you need to remind yourself, and you can use them when you're revising when it comes to changing volume into capacity. A very good example, here we have 24,640 centimeters cubic. Therefore, how do you write these in liters? You only need to come and look at the relationship between centimeters cubic and liters, and here it is. Therefore, you'll say that 1 liter is equivalent to 1,000 centimeters cubic. Therefore, what about 24,640 centimeters cubic? Of course, you just need to cross multiply 1 liter times 24,000. 1 liter times 24,640 centimeters cubic. Then you divide by 1,000. You get? Therefore, that will cancel with that, and the 2 zeros will bring the decimal back here, and you get your answer as 24.64 liters. You get? Therefore, it's easy using this relationship when it comes to conversion of volume to capacity. You can also be told to change these liters into milliliter. You only need to multiply that by 1,000. You know, you get? It's very easy. You can also be told to change the same 24.64 liters into meters cubic. If that is the case, you divide it by 1,000, then you get your answer in meters cubic. Therefore, this is the whole, you know, it's a very simple area to look at, and the only thing you need is to master this relationship and to master the formula for volume, that is base area times height, and with that, you'll be able to proceed. Therefore, so that we can come to the end of the lesson, allow me to leave a few questions here for you so that you can work out, you can work out volume of different shapes. Are we together? Yeah. Therefore, I'll give you 2 or 3 questions, and maybe for, number 1, you can say that work out the volume of the following figures. Yeah, one is A. We have a cuboid, or we can begin with a cube here. And this cube measures 9 centimeters by 9 centimeters by 9 centimeters. Then part B, we have a cylinder. A cylinder has a height of 62 centimeters, and of course it has a radius of 21 centimeters. Then number C, we have a cuboid. There we go. Now our cuboid here has a length of 21 centimeter. The height is 18 centimeters, and the width is 8 centimeters. And maybe the last one, number D. Let me give you a shape that is in half of a cylinder. Because I told you sometimes you will be given such a shape. Like that. The height here is 42 centimeter, and the radius here is 63. Sorry, let me give you the diameter. Diameter, we can make it to be let it be 63. Diameter 63. If I want you to work out the volume of the following figures using the same formula that I've already given you, and see, are you able to find the volume of these different figures below? Because that is what we have discussed with you today. Then immediately you're done. Why don't you try now to, that is convert. Why don't you try now to convert the volume into capacity, that is in liters. Question number 2. Question number 2. You can calculate the capacity of the figures in question 1 in liters. Try to convert the capacity of those shapes in liters. And with that, we have come to the end of the lesson. This is Jeff Wise. I hope you have enjoyed the lesson. Therefore, let's keep on learning. Let's keep on helping one another. Yeah. In case of any question, comment in the YouTube section where you can ask a question, and I believe that will continue well. Thank you. Have a nice time.